3 months before Russia invaded Ukraine, American intelligence knew everything. They knew the exact locations, the troop numbers, the timeline. Russia used camouflage, deception, radio silence, dispersed formations across hundreds of miles. Didn't matter. Every movement was tracked, every staging area identified, every supply depot mapped. The Americans saw everything and Russia had no idea they were being watched. Here is what should terrify you. That was 3 years ago. The system watching then was primitive compared to what's operational now. You don't disappear because you hide. You disappear because the system decides you're invisible until it doesn't. And the scariest part, most of this happens without humans watching. So how does a system like that actually work in the real world? February 2024, the US conducts airstrikes across 7 locations in Iraq and Syria. Targets included enemy rockets, missile facilities, and militia positions hidden in urban areas. The targets were identified, tracked, and validated in minutes, not hours. Minutes. October 2023. Hamas launches its attack on Israel. Within days, over 85 precision strikes hit targets across Gaza. Every single one identified by a system that never sleeps, never blinks, and processes information faster than any human team ever could. May 2010 end. We only learned this in 2024. North Korea conducted a small nuclear test that seismologists dismissed as natural activity. 14 years later, new analysis confirmed it was a weapons test. They hit it successfully for over a decade. That can't happen anymore. Patterns of life. That's what they call it. The system doesn't just see you once. It watches you repeatedly, and the way it does, that is the reason hiding no longer works. When you deviate from your pattern, it notes. When you try to hide, the absence itself becomes a signature. But none of this relied on traditional spy satellites. Those massive billion-dollar behemoths orbiting predictably over adversaries learned their schedules decades ago. They knew when to hide. So if it's not those old satellites doing the watching, what replaced them? For 50 years, the US relied on giants. Satellites the size of school buses, costing $3 billion each, orbiting geosynchronous paths. Incredible resolution, predictable schedules. Adversaries simply waited them out. Hide during the overpass, emerge after they passed. Simple. That playbook is dead. The strategy now is proliferation. Not a few massive satellites, but hundreds of smaller ones in constantly shifting orbits. The result? Persistent coverage. Any location on Earth can be observed multiple times per hour. Since mid-2023, over 100 satellites have been launched as part of a new architecture, transitioning from demonstration to operational phase. And this is only the beginning. The Space Development Agency launched 21 satellites in September 2025, the first of 6 planned launches deploying 126 satellites. These aren't billion-dollar giants. They're cheap, replaceable, and everywhere. The difference is simple. You can't hide from something that never looks away. And these satellites aren't just cameras limited to daylight and clear weather. Modern constellations combine optical sensors, synthetic aperture radar, and infrared detection. SAR satellites see through clouds, darkness, and camouflage. They detect metal, movement, heat signatures. You can hide from cameras. You can't hide from radar that sees through your roof. And this is only the first layer of the system. But even hundreds of satellites watching constantly creates a problem. Too much data, which is exactly why the next layer had to be built. Here's where hiding stops working entirely. Humans get tired. Humans get distracted. Humans can only watch a few screens simultaneously. A human analyst might review 1,000 images per day. An AI system reviews 1,000 images per second. One system can watch more in a second than a human can in a day. And according to the Center for Strategic and International Studies, AI-powered surveillance systems can process and analyze video footage up to 30 times faster than human analysts. Research from the National Defense Industrial Association shows autonomous systems equipped with machine learning algorithms achieve 92% target recognition accuracy compared to 70% for traditional human-operated systems. The Pentagon asked for more than $3 billion for AI-related activities in its 2024 budget submission. That money isn't building better cameras. It's building better minds to analyze what the cameras see. And these aren't simple pattern recognition systems. They predict. The algorithms study patterns. They learn habits. If your convoy leaves the base every Tuesday at 0600, the AI knows. If supply trucks gather at a specific warehouse before operations, the AI connects cause and effect. If communications spike before attacks, the AI predicts the next strike before it happens. Project Maven, the Pentagon's flagship AI targeting program, started in 2017, analyzing drone footage. By 2020, an AI program at Fort Liberty scanned satellite images, identified a decommissioned tank, and sent targeting data to an M142 HIMARS rocket launcher, which then fired from satellite image to artillery strike with AI handling target identification. That was 5 years ago. The technology has advanced exponentially since then. This is where humans leave the loop. But processing surveillance data faster is only half the equation. The other half is making sure every weapon system can see what the AI sees. The Army's Artificial Intelligence Task Force developed a TRMCA-S-aided threat recognition from mobile, cooperative, and autonomous sensors, a networked system of air and ground vehicles that identify, classify, and geolocate targets automatically. Translation: robot scouts that hunt without supervision, autonomous drones and ground vehicles equipped with sensors patrol areas of interest, automatically detecting threats and transmitting target coordinates back to command centers or directly to strike platforms. The Army demonstrated Atlas aboard an M1 Abrams tank, enabling warfighters to distinguish threats humans cannot easily discern. The tank's AI spots camouflaged positions, identifies vehicle types, calculates range, and recommends engagement priorities, all faster than human crews. The U.S. Air Force launched the Advanced Tracking Architecture Using AI program in July 2024 with a $99 million budget, providing next-generation target tracking capable of addressing rapidly evolving threats. This connects to Joint All-Domain Command and Control JDT2. Every sensor feeds into the network. Every platform shares what it sees. The F-35 overhead spots a radar site. That data instantly appears on the destroyer's combat system, the artillery battery's fire control computer, and the satellite network's targeting database. One sensor becomes every sensor. One shooter becomes every shooter. You're not hiding from one platform. You're hiding from an entire interconnected kill web that shares information at the speed of light. And this isn't just a concept being tested in labs. It's being used right now. February 2024, USA. Central Command used Project Maven's computer vision systems during airstrikes across Iraq and Syria. The AI identified enemy rockets, missiles, drones, and militia facilities. Humans made the final decisions, but AI provided the targets. Suler Morcito for U.S. Central Command confirmed the military began deploying Project Maven in real campaigns after Hamas's attack on Israel in October 2023. Over 85 airstrikes were conducted using AI-assisted targeting. The system works like this. Surveillance, drones, and satellites continuously stream video to fusion centers. AI algorithms scan every frame, flagging objects of interest, weapon systems, personnel, concentrations. Human analysts verify AI recommendations. Once confirmed, target coordinates flow automatically to strike platforms. The speed is overwhelming. Traditional targeting cycles took hours or days. Imagery collection, analyst review, intelligence, fusion strike planning, approvals, mission execution. Now, minutes. The AI does in seconds what used to require entire teams working around the clock. And the accuracy is improving constantly. Every strike feeds data back into the algorithms. Every missed target teaches the system what to look for. Machine learning means the AI gets smarter with every engagement. What's already operational is impressive. But what's coming next makes the current system look primitive. The full proliferated warfighter space architecture will consist of 6 orbital planes with 126 transport layer satellites plus 28 tracking layer satellites by 2029. That's over 150 dedicated military satellites in the first phase alone. Future tranches will add hundreds more. The U.S. Space Force is deploying MILNET, a dedicated military constellation of approximately 480 satellites designed specifically for high bandwidth, resilient communications for global operations. That's almost 500,000 satellites providing seamless data transfer between surveillance platforms, command centers, and strike assets. In May 2024, the Space Force awarded Anduril Industries and Capella Space $1.2 billion to deploy 48 AI-enabled SARS satellites capable of autonomously identifying mobile missile launchers with initial operational capability by late 2025. Read that again. Satellites that automatically find mobile missile launchers without human input. The kind of targets that have historically been nearly impossible to locate because they move, hide, use camouflage, and only expose themselves briefly during launch. Now AI will hunt them continuously, tracking their movements, predicting their locations, queuing strike assets automatically. China and Russia are racing to catch up. NATO is integrating AI across its fleets. Hundreds more satellites are coming. The gap isn't closing, it's widening. The implications are staggering. In future conflicts, the side with superior surveillance dominates. You can't strike what you can't find. You can't hide what AI can detect. You can't move without being tracked. This is why Russia struggled so badly trying to hide its invasion preparations. This is why Chinese military exercises are monitored in excruciating detail. This is why North Korea's missile tests are detected before the rocket even ignites. Military strategists talk about decision advantage, ability to observe, orient, decide, and act faster than opponents. With AI processing surveillance data 30 times faster than humans. With satellite constellations providing persistent coverage, with autonomous systems hunting targets continuously, the US maintains an overwhelming decision advantage. It's not that America's enemies can't hide, it's that hiding requires so much effort, so many resources, so much discipline that it cripples operational effectiveness. You can camouflage that tank battalion, but the emissions from their radios still give away their position. You can disperse your forces, but patterns of vehicle movement reveal command relationships. You can operate at night, but thermal satellites see heat signatures clear as day. Every countermeasure has a countermeasure. And the US is spending billions ensuring it stays ahead in this endless technological arms race. Here's the bottom line. If the US military wants to find you, they will find you. The only question is how long it takes. And with AI surveillance, proliferated satellite constellations, and sensor fusion networks, that answer is increasingly measured in minutes, not hours or days. You might hide today, you might hide tomorrow, but eventually, inevitably, the all-seeing eye will find you, because the US military has made staying hidden not just difficult, but almost impossible. And almost is the most terrifying word in that sentence.